So before we really dive in, I think it's important to kind of set a little bit of a baseline and help everybody understand what AI actually is. There's definitely a lot of AI in movies today, but AI in the actual real world. First of all, AI stands for artificial intelligence. And what it is it's the science of computers emulating human decision making. So it's essentially software that can learn and begin to understand context and make decisions a little bit similar to how humans do.
How we use statistical techniques to learn patterns and relationships in data. There's definitely a lot of confusion in the difference between automation versus AI. So I just wanted to kind of set a little bit of a baseline so that everybody's clear on the difference between those two things. Because actually what we see sometimes is that people don't really need AI, they just need good automation. So automation follows pre-programmed rules. You typically see automation being used for optimizing workflows and helping to perform repetitive tasks. So if we kind of think for an example about how the way probably many of your ATSs work, when a candidate comes into the ATS, you might automatically send that candidate an email. That's an automation. You might, for example, be using an assessment software that automatically emails candidates out an assessment once they apply. That's automation. Whereas AI is actually simulating human thinking, and it's learning. It is not something that is pre-programmed. So it is able to find patterns in the data and can self-select how to respond in different types of situations. And we'll kind of give you a few examples of what that looks like as we go. One really good example is the way that resumes can get treated. So I'm sure the majority of you that are using an ATS, it probably has some form of resume parsing technology built into it. And what that resume parsing is doing, that's really automation. It's searching the resume for predefined information, the person's phone number, email address, their name, maybe the university they went to. And it's populating fields that are predefined in your ATS. And that's giving you the ability to screen and search based on those fields. That's what automation looks like. There's a pretty new technology that's out there using AI called natural language processing. You'll also hear it abbreviated a lot, NLP. And that works in a very different way from an automated resume parser. What it can do is it can read a resume similar to the way a human does. It's reading for context and content. So if I look at a resume parser, let's say somebody's title is business development representative. Somebody could be in a almost identical job, and their title could be business development executive instead of representative. Well, if you're going to search for that term in using a standard resume parser, it would only show you the exact group of people based on the text you typed in. I typed in business development representative, so I can't view the business development executive profiles. Whereas with an AI using NLP, it will pull up everybody that has the same kind of context to that. And it's capable of matching candidates directly to job descriptions in many cases. So it's not just looking at keywords, it's looking at the candidate's resume holistically and how it compares to the types of qualifications you're looking for in the resume itself. That's the difference between AI and automation.
Next, we'll talk a little bit about one specific version of AI that's frequently discussed, and oftentimes this is the main thing that people consider with AI and what they've been exposed to, which is machine learning. And this is really the process in which a machine learns from the data it's given. So a slightly different flavor than what Adam talked about. But machine learning is a powerful technique that can be used, but it also has some caveats that we'll talk a lot about today. So an important part of machine learning is this feedback loop that you see on the screen around collecting data, training the model based on that data, testing it, and then over time collecting information again so that you can evaluate how well it's working, you can tweak it and refine it. One of the great things about machine learning is that it's fast and it's efficient. Some would say ruthlessly efficient. A computer will find the best possible relationships in the data, often to the point of overfitting if you let it. And what I mean by overfitting is scoring the input data in a way that predicts the outcome metric so well that it doesn't hold up on or generalize to other samples of data. So that's one of the worries that you have to watch out for. If I'm creating scoring, I want it to be something that will work for me into the future. So before deploying a machine learning model, we always train the computer on a large data set, then we test to see how well those assumptions that we made on that initial data are holding up on a different set of information to make sure that that scoring approach is something that's going to be generalizable and that it's going to work well into the future. And then we often apply it to a totally independent holdout sample as kind of a third check. So you train and test until you feel good about it. And then you do a final evaluation on a totally independent data set just to make sure that it is holding up and delivering in the way that you'd expect it to. Now, machine learning programs allow you to easily train and test results over and over and over again. That's one of the beauties of it. The technique's fairly simple. It's really the automation of that and the ability to do this hundreds of times or even thousands of times very rapidly. And it'll find the best solution that will be generalizable on future samples. But even after that training and testing and holdout process, it's important to continue to collect new data, to not just set this once and leave it running, because things change over time. The effectiveness of that model will decay or degrade as it goes through time because things change. Economic conditions change, candidate interests change, the company's desirability as an employer of choice might shift over time. All of those things are going to have an impact on the effectiveness of that algorithm that you develop up front. And by continuing to feed in new data and evaluating on a periodic basis, you can make sure that the model is delivering in a way that you want it to, and that it provides good results to the organization. So that's an important part. And one of the things you'll hear us talk again and again about is the importance of large data sets and continuing to test and kind of ensure that things are working as they should. So here's a simple example of how you'd train a computer to learn differences on a pretty binary task. In healthcare settings, this is a typical use case. Does an MRI contain a cancerous spot or not? So what you'd do is you could feed a computer thousands of examples of cancerous MRI images and also feed in thousands of not cancer images. You know, it's either one or the other, and you pre-identified which ones are cancerous and which ones are not, and the machine would learn very quickly what to pick up on in those images that is identifiable as cancer, and then would do a really efficient job of being able to identify that on new data over time. So one of the interesting things here is you might choose to just identify the images and then put them into the machine and not be too concerned about how it's actually doing what it's doing. You might deploy some what we call black box or less transparent approaches to scoring that data because ultimately what you care about is the outcome and you want it to be as accurate as possible. So explainability in this case may not be your number one concern. You might give up some accuracy as a trade-off to that explainability. But while this is interesting, it may be critically important in some other cases to have more of an identifiable method to what's being scored and why. That's not the case. So what you'll see with machine learning problems is you have to take into account how the data is going to be used, what the ultimate criteria for success is, and factor that into your decision making as part of this. So what you'll see here is kind of a continuum, and this often becomes a criteria that we'll talk about. Is there's some settings where explainability is critically important, others where you can kind of give it up in favor of accuracy, or just because it's more efficient and less critical in terms of the consequence of the recommendation that you're getting out of it. So we'll talk about a number of these AI use cases. An easy one that everybody's had experience, or most everybody's had experience with, is Netflix. If Netflix is recommending a movie to me, it might be sort of personally interesting for me to understand what's going on behind the algorithm, but ultimately I'll just take the recommendation. It's data, and they've said I'm probably going to like it. I'm probably going to like it. Kind of the same thing with the prediction of the weather. I don't really need to, I don't have a strong need to understand all of the facets of why they're providing that recommendation that they are on the likelihood that it's going to rain the next day. What's interesting in the medical case is while that less transparent approach that's not very explainable in terms of how the machine working can be very, very accurate, a lot of research is starting to emerge that says doctors are less willing to take that input and sort of accept it at face value without the explanation. So you pretty quickly run into some user error or user resistance issues in terms of machine learning. So if the doctors won't pay attention to that advice because they don't understand what's going into the decision, then you've got a user experience problem. You've got user feedback that's saying we have to do something different. We have to be able to explain that model for it to be implemented successfully. And I think that's been my experience within HR. There's a lot of reasons why, but I think most all HR decisions are squarely in the we need to explain it camp, and we'll give some more examples why. Ultimately, candidates that are going through a selection process that you're interacting with from an organizational standpoint have a right to understand why decisions were made about them. And similar to the medical analogy, I think the users, and the users would be HR, recruiters or hiring managers, they're going to demand that type of transparency and connectedness to the job. So it's important to be able to tell that story of what you're identifying from the candidate's signal, from that input information that's helping to predict whether they're likely to be successful. And we'll talk more about that as we go. So here's a quick example of that. We use assessment technology to identify candidates who will be an ideal fit for a role. This is one of the principal things that we do at Outmatch. We do this by measuring people on innate tendencies like personality traits, and then we analyze how those personality traits predict job performance. We do this for our clients over and over each year. And the process that we go through involves learning about the job up front through what we call a job analysis process. We review job descriptions, we look at other documentation like training materials, plus we interview key stakeholders to really understand what it takes to be successful at the job, what the strongest performers tend to look like, and what some of the weaker performers may look like. And then from there, we collect performance data. We typically would have several hundred current employees take the personality assessment, and at the same time, we'd gather performance data on what their supervisors think of them, or if we have objective metrics, even better, sales data, production data, any other type of objective information we can gather. And then we use machine learning to identify those traits that are most associated with stronger job performance. But we feel like it's important, and we need that insight into what's being scored and how, because ultimately we have a responsibility to the client. We have to tie it back conceptually to what relates to the job. So if we use a black box scoring approach where we get a score that says this person's an 87% likelihood of success for the job, that's useful, but it's not really implementable. I can't provide that documentation of job relatedness, and that potentially creates legal risk, and it also makes it hard to communicate back to the business, the recruiters, the HR managers, why we're doing what we're doing. So one of the things that we do with our machine learning approach is machine learning programs can generate feature importance graphs, some of the techniques that you can use, where the emphasis that each feature of the model, and the features here are just those personality traits that I talked about, are shown. So you can quickly see that those with more importance had a strong relationship to performance, and those are going to get more weight in your machine learning algorithm. That's transparent, it's explainable, and it's something that we can connect back directly to the job. So you can see that criticism tolerance was one of the traits that had the strongest differentiation of top performers versus low performers. And then based on the information we heard coming into the job analysis, what we heard up front from those key stakeholders, we can tie it back to those themes that were important for success in the job. So hopefully that's a quick example that provides some clarity on this difference between what we talk about explainable AI versus those less transparent approaches. And I'll hand it back over to Adam to talk about some AI use cases.
Thanks, Keith. So if we look around at some practical AI use cases that are, you can look around and see in our everyday lives. First of all, let's take just kind of a small step back. There are some really interesting statistics out there about how AI will affect the world of work in the coming years. It's projected that AI will disrupt or replace roughly 47% of jobs within the United States alone. That's a huge impact in the next 10 years' time. Already today, if we look at, for example, the financial services industry, AI can be used to detect fraud. It can be used to detect credit default risk, which is one of those issues where perhaps more explainability is more important than less. It's being used in healthcare, as Keith demonstrated, with helping detect cancer cases or different types of illnesses, giving diagnosis for those illnesses. It can also be used to predict the likelihood of hospital readmission. Will somebody have to come back to the hospital after they're released? It's being used in retail. Actually, a great example that I just read that's happening in San Francisco at, I probably shouldn't say the stores, but several different retailers. They're actually using video technology to watch shoppers' shopping behavior and predict how they move throughout the store, what products they pick up in relation to one another. Things like, how do they buy shampoo? They saw something really interesting for me anyways, how women shop for shampoo. And what they found out is that they're not standing around reading labels. They actually open up the shampoo bottles pretty often and smell the shampoo in order to help make their decision. And now AI is then helping those retailers understand that they should put scent samples out for shampoo bottles. It's also being used in logistics. For example, usage patterns, predicting when and where to ship. One really interesting example is there's a company today that has trucks on the road helping support the US Postal Service with no driver in the cab at all. Completely driverless technology being used for 18-wheelers. So next time you're on the road, you see the big 18-wheeler, take a close look and see if you actually find a driver. If we look in our space in the HR world, HR is today, there's applications of it being used to help source candidates. Things like resume matching that I mentioned before. It can be used to, for example, comb your existing resume, your candidate pools, and help you pull out candidates that are already within your system that could be an amazing match for new recs. But it can also be used to, for example, do things like hunt through LinkedIn and other types of job portals for candidates and predict which candidates are a good match for your openings. And there's this new concept of automated talent delivery that's built all around this concept of using AI for sourcing candidates. It's also used for selection purposes. Things like skills-based hiring, which Keith mentioned just a minute ago with our innate traits that we look at. There's an entire field of study around psycholinguistics and body language that can be used to understand candidates better through video interviews. I do caution that one is being looked at a lot with different regulations and potential bias creeping into that. So what psycholinguistics looks at is not just what people are saying, but how they're saying it, their intonation. Do they smile when they talk? Do their eyes get wide with excitement sometimes when they're talking about something they might be passionate about? I think we can kind of see that there are some areas with that that can be potentially problematic in terms of bias. Also, it can be used with retention selection, helping to understand which current employees might be a risk for turnover, and helping identify high potential employees and what could be some amazing next steps for them to help retain them within our organizations. It's also being applied in learning development, helping recommend content that is specific to each employee and helping develop personalized development paths for those employees. So there's already some really exciting use cases of AI being applied in HR, and there's a lot more to come. We'd love to have one more poll to kind of get a good sense of which use case is the most exciting for all of you. One being the automated matching of resumes to job descriptions so that you can better identify which candidates are a good fit for your roles. B is personalized learning development plans. C is helping to predict turnover with existing employees. And D is that video interview with prediction technology that we talked about. You should see the poll coming up right now.
All right, everyone, get your votes in. I see several votes coming in already, so we'll give it just a few more seconds and then I'll share the results. All right, I'll go ahead and close it out. Okay, it looks like we got 30% for automated matching of resumes to job descriptions, 23% personalized L&D plans, 33% turnover prediction, and 13% video interviews with prediction technology.
Great, thank you everybody. I think you just helped me win a bet. So when we're looking at AI, there's a couple things that I think are really important to keep in mind. So first of all, data is critically important to getting started with this, but good data is much more important than just big data. So when we talk about good data, it needs to be reliable. It needs to have all of the different types of input and output, kind of the things that we're trying to predict. We really need good data on both sides of that. And one thing that Keith and I see often is that a lot of companies are tracking their inputs quite well. So for example, the source of the candidate, how long the hiring process took, the candidate's previous job, all those types of things are good inputs perhaps. But what we rarely see companies having really good data on is performance data of the candidates after they become current employees. And in order to make a model really predictive, we need good data around that. Another thing that is critically important to keep in mind is that there can be a lot of ways that bias can creep into AI in ways that you would never expect. One is different types of demographic bias. So in many cases, unfortunately, AI has been shown to be actually biased against women. We've seen this in lots of different cases. If I look at the use case that everybody was most interested in with the AI resume screener, there's been recent studies that have shown that gendered language can creep in and bias models. It's something that I wasn't even very aware of myself until kind of the last 6 months. For example, if a job description has words like aggressive and dominant, those two words are shown to be present in men's resumes multiple times more often than women's resumes. So if that's not being accounted for, men's resumes will be ranked higher than women's resumes with that bias baked into that. And it's a very kind of unfair practice to follow. There's also reinforcement bias that happens very often. We've seen with one of the world's largest e-commerce sites recently that attempted to build an AI resume screener. They trained it off of 10 years of hiring data. So they had big data. But the problem with that data was in the past, their hiring patterns did in some ways favor certain demographics, men over women, underrepresented minorities in some cases. And because the performance data they trained on was the hires that they made in this biased way, the AI was trained in a way that reinforced those biases. So when we're looking at using AI for any form of prediction, it's important to consider all different types of biases that could potentially be present in those models.
Yeah, and I think that's what a lot of it really boils down to is just attending to the basics. So start slow, When we do any sort of research study, we typically are spending upwards of 50 to 70% of our time on pre-processing, data cleaning, evaluating the basic statistics on the data. And some of the things that Adam spoke to really come into play there. So if you're using supervisor ratings, if that's what you're trying to predict, and you have bias in those supervisor ratings, if men tend to be rated higher than women, or if younger people tend to be rated higher or lower than older people, then the result of the scoring, the prediction algorithm, is going to reflect those same biases, because that's what it was trying to fit to. And so it's really important to evaluate the data on both sides before you even go to that next step of putting it into the machine for that training and testing process. That's a critically important factor that can't be said enough. It's important to take a look at that before things start chugging away. And then on the backside, you need to have built-in mechanisms, and we'll talk about some of the questions you can ask of AI vendors, but it's important to have those mechanisms to evaluate for bias on the backside, just to confirm once you get a machine learning model up and running, is it presenting results that are fair, or do you have bias that's crept in? I think the best way to deal with it is just by carefully looking at your data beforehand before you even get started. So on that topic of questions to ask, we've talked about some of these, but I think one of the most important first ones is just, do we have enough data? So we said that good data is more important than big data, but you still have to have the numbers. The smaller the data set is, the more likely that you are to kind of take advantage of statistical chance in building that model, and the less likely it is to hold up over time. So you really would like to have large data sets, lots of data, think in the thousands. When you have larger numbers that are more representative of the population you're intending to use this on, that's going to lead to a better result that's going to hold up better over time. And that's an important first step that you can kind of ask yourself. Does it introduce bias? We talked quite a bit about that, but I think it's important to look at any data and just run all of those basic demographic checks before you get to the point of putting it into the model for that. And any vendor that you talk to should have a plan to audit for bias and audit regularly and be able to report on that and speak to it in a meaningful way. Another question to ask if you're looking at HR software that involves AI is, what's the feedback loop to improve? So like I said, this is not something that you can do once and use for 5 years. It's something that you need to be continually evaluating to check to see how's it working, where are opportunities to improve, and are we seeing some drift in terms of that prediction model over time because of some of those outside factors that might be creeping in. So it's really important to have that concept of a feedback loop as a core part of what you're doing, and to factor that into your thinking there. Another question down there at the bottom left, is external data used to provide better predictions? So I've seen some either less sophisticated machine learning practitioners or people that are just trying to kind of get a product out the door that will validate on your entire data set and not kind of keep anything off to the side to check it on afterwards. And there's a risk to doing that because you can overfit to that data. So if you develop your model on all the data that you have and you don't follow up and cross-validate it or check it on an outside independent sample, you run the risk of it not holding up and continuing to predict well for those down the road samples. So it's just important to have some kind of external data that could be other data from a similar industry. It could be follow-up data down the road, but you need to have that check as part of your process. Something that we touched on a little bit with the medical example, and I gave some examples from an HR standpoint, but I think it's important to do that self-check on how ready is your HR team. Ultimately, you've got to think about what is their level of sophistication, what's their level of comfort with using this data, and ideally get them bought in and involved in the process early on so that they have input into this whole process. They get training on what it can do and what it can't do. They understand that it's not just it's not magic or sorcery, it's just a tool that can be used effectively. And then ultimately, once you move past that, can you explain the results? And I would argue for HR that's really critically important, is to take more of that transparent, explainable approach. And all things being equal, that is important to have. And I'd even sacrifice some accuracy for the sake of explainability, because I think it's so important to be able to tell that story to the candidates and to communicate it inside the organization. This is what we're scoring and why it's being scored that way, and tying that back to the job for defensibility reasons and just for explainability overall. So where does that leave us? What's next? Well, my read on the future, and Adam, I'll ask you to chime in here, is that we definitely are headed towards a world where we have massively larger data sets. You're already seeing that now. Anything that can be tracked or measured is being cataloged and put into databases, and all of that information is starting to be married up more and more. And I think you'll see a future world where these types of machine learning algorithms become very commonplace and are a common tool to use to find associations, to be able to understand the data better, and to be able to predict. I think we're kind of in about halfway through the book. The story hasn't been fully written in terms of where the pendulum swings and where we land around business results versus privacy. I think that there's very little case law that's been written so far. There's not a lot of examples of this stuff that have gone super well or super wrong. And I think more of that will continue to emerge, and that'll affect public perception and how this ultimately is used. If I were betting, I think that we're likely to land in a world where this concept of information equity becomes really important. I think candidates having insight into what's being scored about them and how it's being used in the selection process will be more of an expectation. Candidates will expect that type of insight into what's being stored on them and how it's being used. And I think that's a reasonable ask. I think that from an HR practitioner standpoint, we should be able to articulate how we're using this information and why it's helping us to make better hiring decisions. And if we can't, then we've got to kind of second guess what we're doing there. Ultimately, I think that all evolves to this idea of, I think AI will be accepted. It already is being accepted, but accepted as a tool and not as an overall wholesale solution that's going to solve the world for us. It's a good tool. With some human intervention, it can become a great thing that we can use. And Adam, I don't know if you have any additional thoughts there.
Yeah, so I think it's very easier for us to believe that this is something that's very far in the future. I think actually we're going to be seeing quite a bit of disruption coming near term. I think that if we look at taxi drivers, if we look at truck drivers, call center workers, I think that there's going to be a lot of disruption coming in those three jobs, which are three of the largest types of jobs in the United States, not to mention retail workers and fast food workers, which already have pretty advanced AI applications in the works. But I don't think that we should fall into a trap to believe that this is only going to affect manual labor or blue collar roles. This is also beginning to impact white collar type of positions. For example, accounting. There's accounting AI software already in development and already being deployed at some companies that can actually do a lot of the heavy lifting of accountants' work. Now, we kind of joke about it internally sometimes, but it's really kind of a two paths in the road that we might wind up going down. There's the Terminator path, which is really the autonomous AI, and millions of jobs are destroyed and the AI is making all of our decisions for us. That's one, potential path that this could lead down. But I think that a lot of humans, I think we're going to end up rejecting that. I don't think that that's what we want. And I don't think that's definitely not what we want in the field of HR. I don't think that HR or recruiters in particular want to be replaced. I don't think that candidates want to be just completely judged by an AI and have a score spit out that determines their future life or their future career. I think we'll see more of an Iron Man type of approach that winds up being eventually successful, at least in the field of HR. What I mean by that is big human, little AI. AI enabling humans to scale human-to-human interactions. That's very much the way that we're thinking and talking here at Outmatch. And all of us believe that, a recruiter killer type of product is really not the best way to go.
I think it winds up somewhere where AI becomes a tool that can take care of some of the drudgery, that can automate a lot of the work that we do, and really allow humans to shine and do the things that humans do best, focusing on those high value activities, on nuance, and detail work, all of those types of things to have a better outcome associated with that. And by partnering with it, using it as a tool, we can be more successful together.
All right, thank you, Keith and Adam. Now we'll open it up to questions from the audience. So you guys chat in your questions to me, and while Keith and Adam are answering some of your questions, I will type in the activity ID for your SHRM credit, so you can get that from us here. So first off, Keith, you mentioned that there's not a lot of case law in this area yet because it's still very new, but are there regulations for using AI in HR today?
Yeah, it's kind of interesting. A lot of the existing rules and guidelines are that would be used within human resources date back to the 1970s or 1980s. So you definitely see that the law needs to catch up with the technologies that are used. And a lot of that law still talks fundamentally about the importance of job relatedness, about connecting clearly what you're doing from a selection standpoint to job information up front that's gathered by role discoveries, job analysis, interviews, those types of things. And that's a critically important part of the selection process. Anytime we're doing science for our clients and helping them to deploy an assessment solution, we want to tie that link very clearly. Now, that said, I think there's been some more proactive laws that are being put in place. So I think the state of Illinois, I don't know, Adam, do you know I don't know if it's gone active yet or not, but they're have passed a law that prohibits the use of AI or requires the disclosure of the use of AI and requires a candidate consent to that use before that can be used as part of a video interview. Did I get that right?
Yeah, you definitely did, Keith. That law has been passed in Illinois and affects any candidate applying for a job within the state of Illinois when it relates to video interviewing technology that is being used for prediction. So I just want to draw a dichotomy. If you're just using video interview technology, no problem at all. But if your video interview technology also uses AI to help predict anything about the candidate, especially their fitness for the role or for your company, then you have to be disclosing that you are using AI, and you have to explain how it works. That law goes into effect January 1st of next year. One of the big fears is that might affect candidate dropout rates because candidates might become a little bit spooked by that. So that's just something I want to put out there. We do know that California and New York are also looking at similar laws, mostly surrounding data protection, the use of AI for prediction, and ensuring that it's in compliance with equal employment opportunity laws. And if we look at New York, Illinois, California, that's 3 out of the 5 biggest economies in the US. So regulation is definitely right on the horizon.
Thank you. And someone also asked about Canada. Are you guys familiar with any regulations there?
Yeah, great question. Canada definitely has some strong consumer protection laws and some strong data privacy laws, but I am not aware of any regulation really specific to AI in Canada. Great question, and I will definitely want to do my homework on that to be sure I've given correct information there.
Thank you. Okay, here's another question. For text analysis, is this rule-based or true AI?
Great question. So if we're looking at parsers, that is usually rule-based. Whereas when we're looking at text analysis, typically you would be looking at natural language processing, which is definitely true AI. So that natural language processing, I do want to say, it can be built in a black box way that you won't know where the biases, how those biases are being crept in, and you won't understand the explainability of those models. But that can also be built in a very transparent way where steps can be taken in the pre-processing of those resumes or of that text analysis to remove all things that could be potentially problematic. Gender, zip code, those kind of gendered language issues that I mentioned before, all of that could potentially be removed and still definitely be considered to be true AI.
Is that something where you as the user or the person that's operating with the natural language processing software can run some statistics based on different groups and look at the word prevalence and then make choices about what to exclude to create a model that scores in a more neutral and fair way? Is that the basics of that?
Well, first, I would highly caution trying to attempt to build this for yourself, because you are very likely to run into what that major e-commerce giant ran into, because their data was they were training their model only on their data. When you do that, you're running a big risk of reinforcement bias. So I definitely recommend working at a vendor that has a much wider data set that they are training this model on. And you should be asking that vendor a lot of tough questions around how they're mitigating bias in this algorithm. How do they train their AI in order to do this? And bring up questions like gendered language. That's a really hot new topic and something that a lot of people weren't really aware of until recently. So it's probably not baked into a lot of these products today.
Awesome, thank you. I got another question in. What is Outmatch's specific use of AI?
So I gave that example of looking at personality assessment data and predicting job performance, and that's very much a reality of how we use it today. So we definitely use it with a steady hand on the wheel, where we're using it to identify the patterns in the data, but ultimately we have a human that's evaluating which features are being paid attention to, how much importance those features get, and we're checking off on that before we sign off on it and program it into our final model that we use for prediction. So it's a great understanding tool. It really speeds up our analysis and helps us to work more efficiently and more objectively. But at the end of the day, we have a psychologist or a statistician that's evaluating those relationships, tying it back to the role discovery, job analysis information we have on the front end to make sure that it is something that's explainable and clearly job related. That's how we use it today.
Thank you, Keith. I have another question in, and it is, how about using AI for conducting background checks, pre-employment background checks?
Love this question. So there are definitely companies out there that have products that are doing that. I really caution you to look into how they're doing that, because there are some products out there that are actually doing social media sweeps. So they're actually digging into, for example, the candidate's Facebook page, their Instagram accounts, and they are, for example, we can analyze images using AI, and for example, look at, is this candidate a heavy partier? Are there lots of pictures of them with alcohol in photos? Things like that. And with the very large concern and awareness in consumers and candidates' minds around data protection, especially when it comes to their social media accounts. And the majority of these tools that I've seen are typically not really disclosing that they're doing that. It might just be kind of buried deep in the terms of service somewhere that the candidate is agreeing to. When they have a deeper understanding of how that's being done, I would just be a little cautious that that could be stirring up some bad emotions in candidates.
Where you can essentially give yourself the, is it creepy or not test, and make your decisions from an HR standpoint based on that. That's a pretty clear example that probably is going to feel icky to almost any candidate that finds out you're using it in that way.
Yeah, I think it's a little creepy myself.
Awesome, thank you. I got another question. What is Outmatch's engine? And then a reference to Watson. Maybe is it like?
What's Outmatch's engine? Is it like Watson?
We're not using something, so I would, I'm not an expert in Watson, let me say that first of all, but I would put that more in the world of sort of auto-generated machine learning, where it's finding out this information using deep learning techniques and probably less of a transparent way. It may not be quite as explainable. The machine learning techniques that we use are open source, publicly available. So we're doing most of this analysis through a combination of Microsoft Azure machine learning environment and Python scripts. It's straightforward stuff that you can look up on the web. And what I like about it is it is straightforward. It's soundly based in the statistics and science that we've used for a long time and that we know work very well. And again, just with an eye towards automating and making our processes more objective. So it's really quite straightforward, mostly based on statistical regression techniques and classification techniques.
Maybe if I can just say a little bit about where we're going with our AI usage. We're very much a proponent of using AI to drive insights about candidates, insights about your hiring practices, things like that. And we're honestly a little bit more cautious to use it for pure prediction purposes, and very, very weary of using data like facial feature recognition of candidates, intonation, things like that, where bias can creep in very, very easily. That we are shying away from, and we're very strong proponents that AI must be transparent and explainable. If a candidate should be able to have it explained to them how their score was produced, why they were ranked the way they were ranked, and you should feel very comfortable as HR practitioners that there's no bias being creeped in to that process at all.
Yeah, absolutely. Thank you, guys. That was a really great Q&A. If we didn't get to your question, or if you have a question after the presentation, feel free to email me and I will get you an answer. All right, so thank you again, everyone, for attending today's session on People Analytics and our People Analytics series. Next month, we're starting an all-new HR Buyer's Guide series. So in part 1 of that new series, we'll help simplify the buying process, get tips on how to buy and how to ensure the tech you're buying supports your business and talent strategy. Then in part 2, get tips for increasing user adoption and reaching your ROI goals. I'll provide a link to register in my follow-up email, or you can register at outmatch.com/webinars. Hope to see you there, and thank you, everyone.